not all functions that we want to integrate can be reduced to a simple form or can be reduced to a standard form by doing a simple substitution. Now, what do we do in cases like this? In this lesson, we will develop a unique method of integrating some such functions. Now, the method that we developed today is called integration by parts. Now, what does it involve? This method, the quantity to be integrated is broken into two parts. Now, one part we will call u and the other part we will call dv. If you have identified one part as u, then its differential will be du, and the other part will be dv, and by integrating dv we must be able to obtain v. Now that means the part that you call dv must be a part that can be easily integrated. Well, I will illustrate that by taking some examples. So, the part that we call dv must be a form that can be easily integrated. So, once we have identified u, du, dv and v, we will use a formula that is developed by somebody who worked on this to do our integration. And this is the formula that you need to remember. Integral u dv equal to uv minus integral v du. So, once you have a quantity to integrate, we identify one part of it as u, and the other part will then be called dv. Now remember, the part that you call dv must be a form that can be easily integrated. So once you have u, then you can find du, and you have dv, integrating it will give you dv. So these are the four quantities you need. Once you have these four quantities, the integral of u dv is uv minus integral v du. Alright, let's practice that with this example. Evaluate the integral x e to the power of x dx. And this doesn't actually belong to any of the forms that we discussed so far. That means it cannot be integrated in the normal way. Now, how will we split this into u and dv? What will be your u and what will be your dv? Well, in cases like this, it is conventional that you take x as your u and e to the power of x dx as your dv. Now, the dx always go with the dv part. So, first we identify u and dv. In cases like this, the quantity when repeatedly differentiated will give you 0 will be your u. What does that mean? If you have an x, the derivative of x is 1 and the derivative of 1 is 0. If you continuously differentiate, you end up 0. So in cases like this, that will be your u. So in this case, your x will be your u. So we start by saying u equal to x, and therefore du equal to dx. We have those two quantities now. Now, if x is our u, then the remaining is e to the power of x dx, and that is our dv. Alright, if dv is e to the power of x dx, then what is v? Integrate both sides of this. We get v equal to integral e to the power of x dx, and integral of e to the power of x dx is e to the power of x. So we have u, we have du, we have dv, and we have v. We can now write this integral using the form that we have. Integral x e to the power of x dx is integral u dv. X is our u, e to the power of x dx is our dv. And what is that integral equal to? This is the formula that you need to remember. Integral u dv is u times v minus integral v du. Alright, so u times v, so that will be x times e to the power of x minus integral v du. V is e to the power of x, du is dx, so that will be x e to the power of x, u times v minus integral v du. That's our v, this is our du. Now, this is easily integrated. What is integral of e to the power of x dx? Is e to the power of x. So that will be, now watch this again. That is our u. This is our v, so that is u times v minus integral v. This is our v and this is our du. Now what does this equal to? This will be, that remains the same, x e to the power of x minus integral e to the power of x dx is e to the power of x. So that will be x e to the power of x minus e to the power of x plus c. And you can factor out an e to the power of x. So the result is e to the power of x times x minus 1 plus c. So you can see by integrating this by parts, it was actually made very simple. Alright, another example. Evaluate integral x sine x dx. Now here again, it's the basic form is the same as before. You see, x is something that when you differentiate continuously, it is going to become 0. So we're going to choose x as our u, and the remaining sine x dx will be our dv. So u equal to x, and what is the next step? Find du. Therefore du equal to dx. Then remaining our dv is sine x dx. Alright, if dv is sine x dx, what is v equal to? V will be integral of dv, and therefore integrate the right hand side. V equal to integral sine x dx. What is integral of sine x dx? Alright, it is negative cos x. So again, you have u, you have du, you have dv, and you have v. We can use them to write our integral using the uv form. So what does this become now? Integral x sine x dx is, x is our u, sine x dx is our dv, and what is the form of this integral? That will be u times v minus integral v du. What is u times v? U is x, v is negative cos x, so that will be x times negative cos x, that is u times v, minus integral v du. V is negative cos x, du is dx. So once again, this is our u, and this is our v, that gives you uv. This is the v, and this is our du. And what does this give you? This will be negative x cos x minus, what is integral of negative cos x dx? Integral of cos x is sine x. Integral of negative cos x is negative sine x. Alright, so that will be negative x cos x minus integral of negative cos x dx is negative sine x. And now the two negatives become positive, so your answer is negative x cos x plus sine x plus c. Okay, another one. Evaluate integral x squared e to the